Well, hello, my friends, and welcome back. Today, I want to talk about solving radical equations. I don't mean like, equations that riot or something like that. Marxist equations. Do Marxists use equations? I don't know. No, I mean like square roots and cube roots and fourth roots and maybe other stuff like that. So get something to write with because when you're thinking, and hopefully you're going to be thinking, you should be writing. Thinking and writing should always go together. So let me share my screen with you and we will begin. Before we begin, let's talk about how to solve like this quadratic equation here by extracting the root or by the square root principle. Now a lot of folks want to come through here and they want to square this. So they want to say 3 times x squared plus 14x plus 49 blah 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 blah. No, 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 no. Why do you like to do things difficultly? Is that a word? I think so. You need to extract the root. So what I'm doing here is this. When I'm looking here, first of all, my mind's finding the equal sign, okay? And then I'm like, okay, so I got something simple on the right, and then it's all this clutter here on the left. Where's my variable? There we go. X is my variable. There it is. Oh, it's in a package. What's going on with the package? It's being squared. But I don't have any other x's. So let me just unpack it. And if you've been a student of mine before, you probably know this little situation here. If we do order of operations, parentheses, exponents, multiply, divide, add, subtract, when you simplify things, you go this direction. When you solve equations, you go that direction. So we are doing now reverse order of operations. What do you mean? The first thing that I really have to do here to extract the root is I need to take care of things that are either added or subtracted from the variable group or the package, so to speak. I need to take care of minus 8 first. I'm not going to square root both sides first. That doesn't do anything for my 3, and I can't square root these. I can't square root these two things in pieces. So don't square root both sides first. You need to do that towards the end. Why towards the end? Because exponents are towards the end if you're working from right to left. So the first thing I want to do is I want to add 8 to both sides. Plus 8 plus 8. Okay, this cancels. So then I get 3 times the group of x plus 7 squared is equal to 48. Okay, now what? Don't square root. Okay, because if you square root both sides, at this point, you've got to take care of the square root of that 3 in there. So you're going to square root of 3 times x plus 7. That's not helpful. Be patient, grasshopper. Be patient. So what I need to do then, after I've done the add and subtract, is I need to take care of anything being multiplied, anything multiplying into the group, or anything that divides the group. And in this case, I've got the 3 that's multiplied in. So how do I undo multiply by 3? I divide the left-hand side by 3 and divide the right-hand side by 3. And this cancels and this cancels. And then I get x plus 7 squared is equal to, what is that? Let me do some short division here. If you don't know how to do short division, watch. How many times does 3 go into 4? Once. And how many remaining? 1 left over. How many times does now 3 go into 18? 6 times. Thank you, Mrs. Johnson, who is a 4th grade teacher, I think, that showed me how to do that after I was already an adult and teaching math. But anyway, 48 divided by 3, 16. Okay, now that I've got my package that's being squared, isolated, I've got the group isolated. Now I can square root the left and square root the right. So when I square root the left, I just get the radicand back out. X plus 7 is equal to plus and minus 4. And so then I've got an x plus 7 is equal to positive 4 and x plus 7 is equal to negative 4. Don't leave them in pieces like that. Don't tell me x is equal to negative 7 plus or minus 4. You silly banana. Finish it. So then if I subtract 7 from here, minus 7, x is equal then to negative 3. That's one answer. And then if I subtract 7, x is equal to negative 11. There's my other answer. Okay, there we go. All right. That's how you would solve that by extracting the root or the square root property, or just using my reverse order of operations kind of a thing right there. Well, so now how would you do this one? It's almost the same thing. Yeah? Well, instead of having a square package now, I just have a square root. Look, it equals, and then 40, and then there's a 3 times the group, and then minus 8. And instead of this being something squared, it's now just a square root. Solve it the same way. So what I'm going to do now is I want to isolate this group. Maybe put parentheses around it if it will help you. I need to isolate that group. Well, I'm going to have to add 8 and also divide by 3. What do I want to do first? I want to add 8 to both sides. You could divide everything through by 3, but then you're going to have 8/3 and 40/3 running around, which is not going to be helpful. So let me add 8 to both sides, plus 8. Didn't we just do this a minute ago? Yes, we did. 3 times the group of the square root of x plus 7 is equal to 48. Now, you don't have to put parentheses around there. I'm packaging it for you so that you're aware consciously of the package. Okay. Then divide this side by 3 and divide that side by 3, and I get the square root of, I'll drop the parentheses now, x plus 7 is equal to 16. Now what? How do I undo a square root? Well, I square both sides of the equation. Square the entire left-hand side, squared. Square the entire right-hand side, squared. Now what? I just get x plus 7 is equal to, oh my goodness, what's 16 squared? I should know this. 15 squared is 220. I'm embarrassed. Let me reach for my machine. You're probably faster than me. That's okay. I hope you surpass me in all areas of mathematics. That'd be great. Isn't the teacher pleased when the student surpasses him? Yeah, I think so. So that would be 256. Okay, and then I'm going to get minus 7 cancels. X is equal to minus 6 would be 250. Minus 1 more would be 249. I think that's my solution. So, yeah. Let me give you an alternate way of writing it. Going to the right. Also by rational exponent. Look at that. Isn't that the same thing? It's the exact same thing. Notice my grouping here. I used the square root as an exponent because you know by now that x to the 1/2, anything to the 1/2 is equal to the square root of x. Why is that? Because the index here is 2, even though we don't write it, and the exponent on x is 1, and so you know that if I have the nth root of b to the m, it's equal to b to the m divided by n, right? From a previous principle. So we can go the other direction too, okay? So how would you solve this one? Oh, it's the same thing, except we're doing it in exponent form rather than in radical form. So I would add 8, and then I would divide everything by 3, a little sloppy algebra here, but in the end, I would get x plus 7, quantity to the 1/2, is equal to 16. How do I undo raising an exponent to a fraction? I'm going to raise it again to the reciprocal of that fraction, to the 2/1. So 16 to the 2/1. How does that simplify on the left? Well, what do you do when you raise an exponent to another exponent? You multiply them. So what is 1/2 now? Where's my little laser pointer? Here we go. What is 1/2 times 2? It's just 1. This becomes x plus 7 to the first, right? Because 1/2 times 2/1, that's just equal to 1, yes? And then that's equal to 16 squared. But isn't that what we had before just a minute ago? Yeah, didn't we have that? Same thing. Okay. Now, check your solutions for these. Now, when you first started doing algebra and you did like really, really simple stuff, x plus 2 is equal to 3. Oh, x is equal to 1. Oh, better check that. You're like, oh, okay, just work. That was just kind of in the habit of you learning that the system is working, but this is not that. We trust that you understand that algebra works now and you have some confidence in it. You need to check your solutions because sometimes you can do a solution and get a solution and do everything properly according to algebra. Make no mistakes. You're doing the right thing, and your solution won't work. You say, how is that possible? When you increase the exponent of both sides of an equation, you run the risk of having solutions to that new thing that won't solve the old thing. And that gets into the fundamental theorem of algebra, and we haven't gotten to it yet, so I don't think I'm supposed to talk to you about it. But I'm going to anyway because you need to understand. Do you remember the times when we would do quadratics and we would get two answers and I would facetiously say something like, gee, I wonder why you would ever know that you've got two solutions, and then I would point out the exponent of 2, right? Because the exponent tells you how many solutions. That is a property of polynomials, that the degree of the polynomial in a single variable tells you the possible number of solutions. Actually, it tells you exactly the number of solutions. Some of them may be imaginary, some of them may be real. But anyway, the point being is that when you artificially, as an algebra tool, increase that degree, you increase the possibility of the number of solutions. And then you may have something algebraically that does not then solve the original. So when you increase the degree, you always have to check for your solutions. If you have one that doesn't work, it's called an extraneous solution. An extraneous solution is a solution that you get when you do the right algebra but does not solve the original equation. Okay, so just for the education aspect of it here, I'm going to check this one. How do I check it? I just plug it back in the original. Is 3, there's a big truck driving by. 3 times the square root of, replace x with its variable, or with its thing, 249 plus 7 minus 8, and then there my radical ends. Is that equal to, I don't know, I am asking 40. So now I'm checking this. Okay, so what's 249 plus 7? I feel like I just did this, but I'm going to make sure that I get it right. Plus 7. 256. This is going to be 3 times the square root of 256. Then minus 8. So what's the square root of 256? I feel like I should know that. I bet it's 16. Yeah, 16. Is 3 times 16 minus 8, oops, I'm not finishing, equal to 40? Equal, I don't know, I'm asking 40. 3 times 16 equals 48 minus 8. Does that equal to 40? Yes, it does. Okay, so this one actually works. Sometimes you get one that won't. So you got to check them. So example number 2. Oh no, what's going on here? So okay, we got here's my equal sign, and then I got a square root package, and then there's my variable, and then oh no, I got another square root package. What do I do now? The goal on these is to isolate. Remember I said to isolate your radical. And maybe that's like what the police do in a riot. They isolate the radical, right? The goal was to isolate the radical expression. And in this situation right here, the radical was the square root of x plus 7. So what I did is I got it down here into red where it was x, square root of x plus 7 on one side and then everything else over on the other side. What do you do when you have two of them? Well, you need to isolate usually the bigger one, the one that's more complicated. Isolate the more complicated, isolate the senior, here you go, isolate the senior radical, which we already have. The senior radical is over there on the left. So then how do I undo a square root? I'm going to square the left-hand side. And now watch, and don't make this mistake. I have to square the entire right-hand side. You must use parentheses. I'm not just squaring each piece. It's the squaring the entire side. Whatever you do to one side of the equation, you must do to the entire other side. So now, the left side simplifies fine. X minus 12. But how do I square the right-hand side? If you wanted to, you need to like multiply it out. It's going to be 2 minus the square root of x, and then 2 minus the square root of x again, and you're going to have to, you know, FOIL the thing and so forth. When you get that finished, you should have, let's see if I can do it with a pattern. There is a special pattern, right? You realize that if I've got a plus b, quantity squared, it's equal to a squared plus 2ab plus b squared. And if you're an algebra student at this level, you should know that and know how to use it. I'm going to do the first thing squared, so that's going to be 4. And then it's going to be a minus sign, and then I'm going to take 2 times the square root of x and then double it. So it's going to be 4 square root of x. Okay? And then the last thing is going to be a plus, always a plus, plus the square root of x squared, which is just x. There we go. Double check me, but I think I'm all right. Okay? So now what do? Well, okay, I've still got a radical. I canceled the one on the left, but I still have one on the right side of the equation. I need to isolate that one. So I need to get this guy all by himself. The first thing I notice is that I got an x on both sides, just plus x and plus x. If I were to subtract x from both sides of the equation, both of those would cancel. So that's like, that's gone, okay? And so let me do this at this point now. This is positive 4. Let me subtract 4 from the right and subtract 4 from the left. So this is negative 16 is equal to negative 4 now times the square root of x. That's what I have when I simplify. Okay? All right, so now what do? Well, I need to divide both sides by negative 4. Divide this by negative 4. Divide this by negative 4. A negative divided by a negative is a positive. That's going to be 4. That's equal to now the positive of the square root of x. And now I square both sides a second time. Square the entire right, square the entire left. I get x then is equal to 16. Bada bing. Let's check it. So do the check right here. I'm going to take the original thing. I'm not going to check it like down in here in the middle. I'm going to check it in the original thing. So is the square root of x, which is 16, minus 12, is that equal to, and again the question mark because I'm asking it, 2 minus the square root of 16. Okay, let's see here. 16 minus 12, that's the square root of 4. Is that equal to 2 minus the square root of 16, which is 4? Is 2 equal to negative 2? Oh no! Yeah, it doesn't work. I'm sorry. I thought you were the one, but you're not. You are an extraneous solution. But that was the only one we had. So what's the final answer to this? No solution. There is no single x value that you can plug into that original that would make the statement true. It's impossible. So, now let's see, how would we do something like this? Take a look at it. It's in exponent form, not radical form. Do you find your equation right here? Here's the equals. Okay, did you find your x? There it is. Oh, it's in a package. What's going on with the package? Oh my goodness, it's being raised to the 1/3. You do remember, though, that this means the same thing. I can rewrite this as 2 times the cube root of 6x minus 3, close the radical, minus 4 equals 0. That's the same thing. Okay, right? You realize that? It's the same thing. The 1/3 power is the cube root because it's that to the first. All right? But eventually we want to move away from radical form and we want to use exclusively exponent form. And so if you have a radical, then you've got to write it as a fractional exponent. So again, same process. I only see one variable, so let me isolate the radical. And there is a radical here. I want to isolate the fractional group right there. I'll do that by adding 4 to the right and adding 4 to the left. This cancels. So I get 2 times the group of 6x minus 3 to the 1/3 is equal to 4. Divide this side by 2, divide that side by 2. You got to do those things first. Don't try to cube both sides to undo the exponent until you isolate the exponent. And so then the exponent package becomes 6x minus 3 to the 1/3 is equal to 2. Now I can undo the exponent, right? Just to remember, if I'm doing parentheses, exponents, multiply, divide, add, subtract, I have to work backwards. Okay, so the adding of the 4 was doing this one right here, the subtraction. I got to undo the subtraction first. Then the dividing of both sides by 2 was undoing the multiply. Only after I've done those things can I now address the exponent. So now let me address the exponent. How do I undo an exponent of 1/3? I raise it to another exponent, and what exponent would that be? The reciprocal of the one I'm trying to cancel, 3 over 1. In fact, I'm not even going to write it as 3 over 1. I'm just going to write it as 3 because you're savvy enough now to manage that. Okay, so this cancels, and I just get the base. 6x minus 3 is equal to 2 cubed? Don't tell me 6. 8. Okay, so now I can finish doing what's inside the parentheses, see? So now I'm going to do like plus 3. This cancels. 6x is equal to 11. Come on, pen. 11, there we go. And then so then divide both sides by 6 and divide both sides by 6. And so x then is equal to 11/6. Don't be afraid of fractions. Check it. Okay, here we go. I'm going to check over here. 2 times 6 times 11/6 minus 3 to the 1/3 minus 4. Is that equal to 0? Wow, let's see. Okay, doesn't this 6 and this 6 cancel? So doesn't this gives me 2 times, isn't that just 11 minus 3 then? 8 to the 1/3 minus 4 equal to 0? Yes. What does the 1/3 mean? You may want to switch back to radical for this. Isn't this the cube root of 8 minus 4 equals 0? So this becomes 2 times, what's the cube root of 8? 2 minus 4 is equal to 0. Is 4 minus 4 0? Woohoo! Works. So isolate your radical package. Undo the radical by some exponent. And if you're using fractions, you need exponents. You're using radical symbols, still it's exponents. And then work inside the parentheses. But check your solutions. Okay. This is easy now. Like, this is boring. All right, so this one, I see the equal sign. I see my variable now, which is n. It's in a package. It's the 4th root, and then it's all in the group, and then I got the 3 over here. If you wanted to write it in radical form, you could do it like this. This would be 3 times 2n plus 6 to the 1/4 minus 6 is equal to 0. That says the same thing, so get used to seeing both of those. Okay, so now that we've mastered the radicals and we make them serve us, let's put it to use. All right, so I'm going to have to add 6 to the left, add 6 to the right, cancellations. 3 times the 4th root of 2n plus 6 equals 6. Divide the entire left by 3, divide the entire right by 3, cancellations. 4th root of 2n plus 6 is equal to 2. How do I undo a 4th root? Well, I raise it to the 4th, and I raise this entire side, even though there's only 2 there, to the 4th. The exponent cancels the root. I get the radicand. 2n plus 6 is equal to 2 to the 4th. 2 cubed is 8 times 2 more, 16. Subtract 6. Minus 6, cancel. 2n is equal to 10. Divide by 2, divide by 2. N is equal to 5. Is it? Is it? Is it? Let me see if I can do this real fast. 2 times 5, that's going to be 10. 10 plus 6 is 16. What is the fourth root of 16? 2. What's now 3 times this whole thing, which is 2? That's 6. Is 6 minus 6 0? Okay, I think it works. Oop, yep, time for exercises. Alrighty, so for solving radical equations, isolate the radical package and then raise both sides of the equation to the exponent that would cancel the radical, even if it's a fractional exponent. And you might have to do it twice or so, because if you still got exponents or radicals left over after the first time, you got to repeat the process again. But always check your answers, because you might have an extraneous answer. Sometimes you do everything right and you still are unsuccessful. Isn't math great? Here we've done everything right, and sometimes we don't have a solution. Sometimes it's possible in life to still do everything right and still not have it work out the way you'd like it to work out. And that's not life being mean at you, and that's not you doing something wrong. If you've done everything that you can do, and you've done so rightly, and you're still not successful with the thing, then the fault or the problem or the obstacle is not you. So be at peace. You got to kind of let it go. So, yeah. Mathematics is one of those things that the principles of math can be used outside of math in some areas, and they help us to sort things out. So that's why you should study math, even if you never use it in your job. It's good. It teaches your mind to think, and to be patient, and to reason, and then be satisfied with the conclusions that you come to. Anyway, have a great day. Bye-bye.